Okay, I'm really happy to introduce Brad Nielsen. Brad has spent the last 5 years teaching IT at Marist College in Queensland. He was not always a teacher. He has a degree in multimedia and IT and previously worked in IT for 5 years as a consultant and a web developer, specializing in online learning and learning management system software. So, thank you, Brad.
Thank you. Okay, hi everyone. Cool. So what I want to talk about today is just how I've gone about integrating Python within Marist College. Marist College is an all-boys school in Queensland. It has 1,600 students, and when I got to the college, there wasn't any programming being taught. Certainly not text-based programming anyway. So as I'm the only IT teacher at the college, I was given the task of revamping the curriculum, and this is very much starting with a clean slate, which was good and bad because it was a challenge, and it also meant that I could do things my way. So I had to choose a programming language, and I settled on Python for the following reasons. One, the school is a bring your own device school, so I wanted a programming language that would work on different devices, and Python's interpreted, so for me it seemed like a good fit. It lacks the complexity of Java and C#, so students can worry about programming rather than having to worry about keywords and method declarations. Code formatting is strict, so the fact that Python requires indenting I think is a great thing, because if kids don't learn to format their code, it's a habit that will haunt them, I think, for the rest of their coding lives. So having strict formatting improves the readability of their code, and also I think helps them understand the code as well. Also, because it's open source, I thought there was many libraries and packages available, and I was also encouraged by the fact there was a lot of tutorial software that I could lean on a little bit. Knowing that I was teaching Python from scratch and that all the different grades hadn't done any Python, it was going to be a massive task if I was to do too much direct teaching. So tutorial software could help in that regard. And finally, I also knew that a lot of universities were starting to use Python as a first-year language. And so any way I could give my students a step up when they go to university seemed like a good thing. There was difficulties to implementation. Firstly, the lack of prior knowledge. So starting from scratch in a school, I couldn't expect too much of my Year 11s and Year 12 students in terms of what they could produce unless they had some kind of background to draw upon. So I really needed to actually look at introducing Python slowly within the school and developing that prior knowledge before going onwards to big projects. Sourcing software and devices was difficult, not because there isn't a lot out there, it was just because you learn these things with experience, and once you've tried a particular piece of software with students, then you know whether it's any good or bad. So it was difficult without that experience, and it was something that I had to develop over time. Also, the lack of IT teachers. Having more than one IT teacher would have been beneficial, as in I could bounce ideas off someone else. And being the only IT teacher in the school, where there is a cohort where we're expecting to teach some kind of digital technologies curriculum across the whole cohort, then I'm really having to rely upon other teachers who haven't really been taught the same type of skills in terms of coding. And then finally, lack of time allocation. And this is an issue for most schools. Certainly, because IT had died down a lot within Marist College, there wasn't much interest amongst students. The current curriculum, the curriculum they had been taught very much was Word, Excel, spreadsheets, that kind of stuff. It was very dry, and students weren't attracted to the subject. So there had to be I mean, as I am drawing interest into the subject now, but it's really then having to fight for time allocation. And one thing about teaching in a large school, teachers are very protective of their particular subject areas. So if you take a term of IT away from another teacher, then you do hear complaints. So the lack of time allocation towards IT was another issue that I had to deal with, especially if I wanted to build some type of progressive approach to programming. So the solutions I found, and this is my 4th year in terms of developing that curriculum within the school, or 4.5 years now. And what I found is taking an incremental approach, so not expecting things to happen too quickly, but at the same time knowing where you want to go. And I found that now that I've got year 11 and 12 students who've learnt stuff prior to year 11 and 12 in years 8 and 9, all of a sudden I'm finding their abilities in terms of programming are getting better and better. So much so I'm starting to be increasingly amazed by what they can produce now. But I couldn't always do that. So for my year 11s and 12s, I'm only starting to see the fruits of my labour now. But in previous grades, I couldn't expect too much of them because they hadn't had that type of experience. Collaborating with other schools, so things like this here, and also being on QSite, which is a Queensland type of discussion list around introducing ICTs in schools, has been very beneficial because I can see what other schools are doing and then take those ideas and implement them with my students. And certainly I've done that. Just listening to some of the presentations today will guide me in the future as well. Finding online tutorial software. I'm going to talk about Grok Learning later, but like I said before, it's been a great help to me, not because I just want the tutorial software to teach all the students, but because it's allowed me to do a bit of direct instruction with my kids and also sit back and be more of a facilitator role. So I can allow students to go through the software and I can help them when they have issues, or I can extend them as they're going forward, rather than constantly having to keep the class on one level and waiting for the stragglers in my class. I can push them ahead. Pushing for time allocation to the subject. I'm happy to say now that the digital technologies curriculum has been released. The school is really pushing into creating more time for the years 9 and 10 to get more experience with the IT curriculum. So as of next year, we're looking at having a whole semester subject for year 9s across the whole cohort. And that's never happened before. So that's starting to happen now, and that poses challenges in itself too, in terms of resourcing, because then you've got to start thinking about what kind of resources you can use for a whole cohort of students rather than just a class of 20 to 30 students. And then finally, one of the things I've found really beneficial to myself is the use of clubs. Because I have 2 clubs in a year. I have a 3D games club in first term, and then I use a robotics and electronics club in third term. And those 2 clubs allow me to kind of test software and devices on students. And they're much more cleverer than me in some ways. They've got more time to spend. They're more interested and engaged. I've got to think about too many other things. So allowing these kids to explore the devices shows me what can be done with them, rather than me just pushing what I know onto the students. I'm allowing them to research for me. So in a way, I'm kind of using my clubs as a set of guinea pigs, you could say. But it's really working, I think. Okay, so I want to explore the programming sequence at Marist now. And with context, as in that even though this is very much Python related, I am going to also discuss some concepts and other types of areas that feed into later Python projects. And I think if I didn't actually provide that context, it'd be giving a bit of a disservice. It doesn't give a clear view. There are certain precursors that are required before I get to the larger Python projects that my year 11s and 12s do. So as of this year, I've started introducing programming into years 5 and 6. At Marist, we have a group of, say, 80 year 5 students and 80 year 6 students. and then our big, large intake is at year 7. So for them, I'm very much interested in doing visual block coding, so they understand the fundamentals of coding. And also I'm trying to make coding really fun. So I don't want them their only experience with IT is doing spreadsheets and Word and stuff. I really want them to get involved, get interested, and provide that opportunity there for the kids to actually then explore what they can do outside of the classroom, perhaps as a library activity or something like that. So I've very much gone into the robots for them. I've purchased Ozobots for the year 5s. Ozobots are these small miniature robots that can actually, they pretty much are coded via colour. You can even hold them up to a web browser and use something called Ozoblockly, which is like Scratch, and it will flash all the colours in and then program the robots to go around. So it's good because it teaches students some of the fundamentals of programming, and it's a very visual and interactive way for students to learn things like deconstructing a program or constructing a program and extending it. So for the year 5s, that's worked really well. Year 6, I'm starting to bring this in for next year. So I've purchased some drones, being the Sphero, the Mini Parrot and the Ollie. And I've also been playing around with Tinker, which is again like a Scratch program for the drones. The only issue there is Tinker only works on tablets, unfortunately. So I'd prefer them to actually be using either a web browser or using just a normal PC rather than having to rely on tablets. We do have a set of tablets in the primary, so it's not a big issue, but very much I'm conscious of the fact I'm trying to make it so with the school being a bring your own device school, I'm trying to make sure that the programming applications they use are device friendly. Okay, so then we go to year 7, and this is where we're starting to transition from visual block coding to text-based coding. Now, year 7 is our big intake. So in year 7, we get 240 students come into the school. So every grade has about 240 students, except for year 5s and 6. And so we start teaching them using Scratch. We don't know where those students have come from, so we don't know what amount of programming they've previously learnt. So we are starting from basics again, but I think Scratch is a good way to do it. One, it can cater for the whole cohort because it's 240 students. 2, it's free and it's in a browser, so it's very easy for them to program. And also, we also are integrating that into an art and a music subject. So what they do is the students create both music, like game music, and they create artwork for their game, and then in Scratch they bring it all together and program their game. And all students in year 7 do that. We finish off using something called Code Combat. Code Combat is really, really good. In fact, I know my brother's using Code Combat to teach his 7-year-old son now Python programming. Code Combat's like it's a gaming interface, so it's like the gamification of Python programming tutorials. So students go around these mazes and they have to type Python code to solve the maze. As they get gems, they get experience points and they can purchase items, and then as they purchase items, they get things like a sword, and then the sword allows them to use other functions, and then they can use the sword to attack enemies. It really is a fun game, and students really, really love it. The only problem I find is that and I use this in year 8 as well, both in year 7 and year 8, in terms of the time allocation, I've really only got 3 or 4 subjects, 3 or 4 lessons each year in which the students can use Code Combat, where it's actually using class time. And that's quite a big limitation, really. So it's something that they can really get into. I still find that within those 3 or 4 lessons in that year, the students can normally finish a module. So the idea is in year 7, and this is their first taste of Python too. So the idea is in year 7, they finish the first module, and then in year 8, as part of the tech subjects they finish the second module. And then if they finish both modules, then I'll let them play Minecraft, which is a pretty good incentive for the kids. Okay, so year 9 and 10, now this is something that will change next year. At the moment, we have elective subjects. So each semester, we have semester units, and the students can elect to do the IT subject that we have going. So there's 2 subjects across year 9 and 10, and they can alternate based on their timetable. They can alternate when they do both those 2 subjects if they wish to. So it's an elective subject. So normally I would say in terms of a student cohort, I'm getting about 40 to 50 students out of that cohort elect to do the subject. Next year that will change. So next year all year 9s will have to do the semester subject in IT, which is going to pose a whole lot of problems or challenges to me in terms of structuring their curriculum. Now, I'm a big fan of Grok Learning. And that surprises me because I'm always on the lookout for free software, and Grok Learning actually costs me money. But I think it's worth it because I've tried using things like Khan Academy and Khan Academy and Code Academy. Sorry, both of them I think take the kids through the programming process too quickly. So it's actually it's not good as in that the kids don't get regular programming exercise. They really need practices at a basic level before they move on. So it really needs to be kept reasonably simple and have a nice progression to it rather than throw them in the deep end and then all of a sudden they struggle and they get frustrated and they get turned off programming. So I think Grok Learning is good in that way. You can even see, I like the fact you can keep track of the students' progress too. So it keeps students accountable. So you can see in that top right corner there, I've got students and I can actually look at how many problems they've solved, what problems they're having trouble with. So for me, it's a great way to keep track of my students. The only criticism I would have of Grok Learning is that I think it actually takes too long to introduce the idea of a function to students. So you'll actually find functions is actually in the second programming unit, whereas if you've used Python a lot, functions are used all the time, even from the start. As soon as someone types a print command and they use round brackets and they put in a string, they're using a function. So for me, I actually think functions should be taught a bit earlier. And so what I do is I normally mix up Grok Learning with a few lessons of direct instruction, where I will actually go through and teach those types of concepts. And the other thing along with that functions idea is the idea of indenting code. I think that's probably one of the most difficult concepts for students, is that when you indent code in Python, you're actually creating a continuous block of code. And then once you break the indent, all of a sudden it's not running that block anymore. So it's something I like to emphasize at the start. Otherwise, I think Grok Learning is great. And I use Grok Learning for my year 9s and 10s and also into year 11. So we go into year 11 and 12. I just wanted to, before we go into year 11 and 12, I just wanted to also show you, I've highlighted in yellow some of the other concepts that they're learning. This isn't all that I teach them in terms of the IT curriculum, but it's important because these concepts or applications are actually used within my year 11 and 12 course. So I actually teach them a bit of web development in year 9. I also teach them object-oriented programming, the principles of it, using the application GameMaker. And I actually think GameMaker is a really good application for this because it actually teaches them that objects have properties and functions. It teaches them how you can create instances of objects. It also shows the student how a basic game would work. So the fundamentals of a game being that you have a game loop, and then the game loop runs the logic of each object, and then it renders every object to screen. So GameMaker is really good for this, whereas I don't think it's necessarily that good for teaching students text-based programming. You can use the language GML to do text-based programming, but I feel like it's a bit of a hurdle for the students. They're not up to that point where they can do much to it, whereas it's great for teaching object-oriented programming, even using the iconic type of programming interface that GameMaker uses. Finally, we finish off year 9 and 10 with a bit of App Inventor and also a bit of Microsoft Access, and we introduce SQL, which will come in handy when we get to year 11, year 12. So year 11, year 12, the students are expected to do major projects. And a major project takes the whole term for the students to complete. With year 11, I get the students developing games using Pygame. And this is, like I said, this is an incremental process. So I do give them the option to still use Game Maker if they wish, because I consider Game Maker a bit easier, and the students consider it a bit easier. But they're encouraged strongly to go the Pygame way. And I also tell them, well, if you want to get an A for your project, you're better off using Pygame. So I make it very clear to them that I would prefer that they challenge themselves using Pygame rather than settling for something that's a bit easier in terms of Game Maker. Year 12's, their major project is an online database-driven website using the Python package Flask. And I found Flask is very effective in teaching kids how a web server works. And you'll notice that I've also got there that it interacts with SQLite. So as I was saying, the year 9 and 10 subjects actually lend itself to the year 11 and 12 subjects, as in there's certain skills they have to know. The year 12 project really is a culmination of everything they've learnt through school. So they've learnt programming, they've learnt database design, they've learnt SQL, they've learnt the web development, and they're combining it all together in one final project. So it's a nice way, I think, to consolidate their knowledge and also encourage themselves to stretch themselves and create something quite complex. Pygame, I think, is a great way to teach object-oriented programming, because students have to actually code from scratch the objects that they're going to make. And so they're very much learning the object-oriented principles that they did in Game Maker, but they're actually now practicing it in terms of coding structures. Okay, I might just show you a game that one of my students has made. This is where I'm starting to see the fruits of my labour, because I've got 3 students in year 11 who their Pygame application is just amazing. And there's like this friendly rivalry between the 3 students as well. So most students actually chose to do Pygame. Not all of them did, but most of them did. And so I'm starting to see that progression of programming skills. And in terms of the programming, I mean, to be honest, this is almost university level programming. I can't mention just how impressed I am by it. I don't know if you can hear the music, but this, he's got a little snowman that goes around. So you collect all the blocks. The monsters can eat the blocks. And I can actually make blocks as well. And probably that's what I'm most impressed about, is that this student has got this multi-dimensional array of blocks that he can also add to in terms of his program. Yeah. Anyway, this is something like, if you use Game Maker, you could make something like that very easily. But using Pygame, that is a massive achievement. It takes significant programming to do. And he's learnt all those concepts to do with object-oriented coding to do so. And he wasn't the only one. Like I said, I got 3 students in that class who've got an A+ for their project. And that's because they've learnt Python from a young age, and they're starting to now practice it. I also want to show you Flask. you would have heard, you would have heard of Django, for example, and Django is good as in it's a Python web server. The only thing I'd say about Django is it's very abstract. The students don't really interact with the SQL code that they do with Flask. So Flask is a web server that they can create, and it allows them to interact with SQL and also allows them to create a series of request handlers. So I've actually got 3 students in Year 12 who've made themselves multiplayer games using Flask, although this one obviously isn't working at the moment. It's hard to demonstrate anyway. This student in particular has actually created both a Norton Crosses grid and a chat room. So he's actually really gone far and above what he had to do. It was a project where they just had to create an online database. They could do whatever they wanted with it. The minimum was they had to actually be able to register a user. They had to be able to log in. And he's gone ahead and used both Python, Ajax, JavaScript, you name it, to create this online application. Just to conclude, because I know I'm running out of time, he's also created this using, and this is the Flask programming here. He's created it using a cloud computing platform called Python Anywhere. And Python Anywhere basically allows you to create your own web application of Flask, sets up all the files for you, so there's no configuration issues. The students are programming within the browser, which ticks all the right boxes for me. I try to avoid projects where students have to do massive configuration issues. Okay, so I'll wrap it up there because I think I'm out of time. Does anyone have any questions?
Let's thank Brad. Yep. So, do we have any questions? Yes. Yep.
Do you find that they work well individually, or are you teaming people up and doing pair programming and things like that? And what's worked well for you there?
I actually have minor projects, like just a normal database where I let them work in pairs. I also have a robotics project they're doing this term in Year 12 where they get to work in pairs. But they're the minor projects. The major projects, I've actually told them they have to work by themselves. Just because I think students hide themselves when they're in groups. And the other thing is, and I was having this discussion before with Tim over there, at our school, we don't do a lot of group projects. And I think it's actually an issue that the students get to Year 12 and they don't know how to work in groups. So I'd love to do some more group projects, but it's difficult when students haven't done a lot of group projects, and they do there's always 1 or 2 students that hide. The other thing, and this came to me before when I was watching Bruce's presentation, is the idea of ill-defined projects. I've struggled with, I'd love to put more ill-defined projects in my classes. The problem, however, is that some of my students, if you give them an ill-defined task, they always have a thought bubble. Sometimes you get these students who just constant thought bubbles. Every day it's a different project or a different idea, and they never actually get started on the project. So what I've tried to do is, with my projects, I structure it in such a way that it is individual for the major ones, but I also tell them this is the minimum requirement. You've got to get to here. So there's no ill-defined problem. They know they have to get to that point. After that, then I say, okay, now to get above a C, you've got to come up with something. And so that's where the ill-defined project comes into it. But yeah, structuring the assessment is definitely a challenge.
I think that's all the questions, unless anyone has one more. Nope. Okay, thanks, Brad.
Cool.